Today's lesson is on solving systems by elimination. So last lesson we did substitution. This time we are doing the third method, which is using elimination. So the first method was graphically, second method was substitution, and the third way we're going to learn is all about elimination. So when we're doing elimination, we're going to look to see if there are like terms between either x or y. If there isn't, you have to multiply by a like term to make the coefficients the same. You set up one equation subtracted or added by another equation, and you eliminate one variable and solve for the other. You're going to substitute that answer into one of your original equations to solve for your other missing variable. That might sound confusing, just like it did in the last lesson. It will all make sense as soon as we go through a couple examples. So let's take a look here. I have a 3y and a 3y here. So what I can do is I can type these up, set these up as equal to each other, or not equal to each other, one over the other, like we're adding or subtracting. So when I do that, I have 2x minus 3y equals 15, and I have 5x plus 3y is equal to 27. Now what I need to do is I need to determine, am I adding or subtracting to get rid of a variable? So the variable that has the same coefficient is my y. And if I need to know if I'm adding and or subtracting to get rid of that, I have a -3 and a +3. If I add those two together, I get 0. So we're actually going to be adding these two things together, just like you normally would. So when I add them together, I have a 2x plus 5x is 7x. 3y plus -3y plus +3y gives me a 0y. And 15 plus 27 is going to give me 42. Now I can take this equation that I have here and I can solve. So I have 7x is equal to 42. I can divide both sides by 7. And I'm going to get x is equal to 6. Now I can take that x equals 6 and I can sub it into one of these two equations. It does not matter which one I sub it into. So I'm going to take the equation 2x minus 3y is equal to 15. I'm going to sub in 6 for x. So I have 2 times 6 minus 3y equals 15. So 12 minus 3y is equal to 15. I'm going to subtract 12 from both sides. I'm now got -3y is equal to 3. And I'm going to divide both sides by -3 to get y by itself. And I get y is equal to -1. When I have y is equal to -1, and I have x is equal to 6, that becomes my solution. So my solution is now over here. Let's go with our solution. Is x equals 6, y equals -1. So as a point, I have the point 6, -1. And you can once again check, verify your answers by checking. So I can go 2 times 6 minus 3 times -1 equals 15. If I type that into my calculator, I should get 15 equals 15. And for the next one, you can also do the exact same thing. So 5 times 6 plus 3 times -1 equals 27. 30 plus -3 will give you 27. So 27 is equal to 27. That tells me that my solution is correct. So this here is a good solution. It works. Everybody's happy. Next equation here, I have a 5x here and a -5x here. So I have a common coefficient. I can go through, I can set them up, and I can add and or subtract them as needed. So let's start with 5x plus 6y equals 32, and I have a -5x plus, or minus, sorry, 2y is equal to 12. Now I need to know, am I adding or subtracting these two things? Well, if I wanted to add them together, it would definitely help me get a 0x. So I'm going to add these two together. 5x plus negative 5x is going to give me 0. So we're going to stick with that. So we have a 0x, and a 6y plus a negative 2y is going to give me 4y. So plus 4y is equal to 32 plus 12 is 44. Now, when you're setting this up, remember to line up your variables. Your x variables, your y variables, and your standard number should all be lined up properly. So I now have 4y is equal to 44. I can divide both sides by 4. And I'm going to get y is equal to 11. I can now take that y equals 11. I can sub it in into one of the other equations, and I will wind up getting a solution. So let's sub it into this first equation here. So I'm going to go with 5x plus 6y is equal to 32. And I'm going to sub in a 5x plus 6 times 11 equals 32. 5x plus 66 equals 32. I'm going to subtract 66 from both sides. And I'm going to get 5x is equal to negative 34. I'm going to divide both sides by 5. And I'm going to get x is equal to negative 6.8. I can now say that my solution is x equals negative 6.8 and y is equal to 11. So I have the point of negative 6.8 comma 11. And I can verify my answers by checking them. So I can now go 5 times negative 6.8 plus 6 times 11 equals 32. If I type that in my calculator, I should get 32 is equal to 32. And for the second one here, I have negative 5 times negative 6.8 minus 2 times 11 equals 12. And when I type that in my calculator, I get 12 equals 12. So both my answers check out. They've both been verified. That means that this here is my solution because it verified when I checked it. Third example here. So when we're looking at this one, I don't have any coefficients on any of my variables that are the same, so I have to make them the same. And in order to make them the same, I'm going to have to multiply my equations by something. So I'm going to deal with, in this case, I'm going to change my x's because they're not as big of a number. So in order to do that, I have a 5x and a 3x. I have to find a common number. I'm going to multiply this equation by 3, and I'm going to multiply this whole equation by 5. And the reason I do that is I can then get a 15x and a 15x. So when I go through and I do that, I wind up getting 3 times 5x plus 3 times 4y equals negative 28 times 3. So when we're distributing, we have to distribute it to everything within those brackets, so every single term. So I get 15x plus 12y is equal to negative 84. And for this one here, when I distribute it in, I get 3x times 5. So I'm sorry, 5 times 3x plus 5 times 10y equals 5 times negative 13. And when I do this, I get 15x plus 50y is equal to negative 65. Now I have two of the same coefficient, so I can actually add and or subtract my equations now. So I'm going to go 15x plus 12y equals negative 84, and I have 15x plus 50y is equal to negative 65. Now I am needing to determine if I'm adding and or subtracting these two things. So when I do this, I need to get a 0 here, so I'm going to have to subtract them. So this is going to go in brackets because it needs to subtract the whole thing, just like we would in numbers. So when I'm subtracting, I wind up getting 15x minus 15x is 0x plus 12 minus 50y is going to give me negative 38y, and negative 84 minus 60, negative 65 is going to give me minus 19. So I now have negative 38y is equal to negative 19. I'm going to divide both sides by negative 38. And I'm going to wind up with y is equal to 0.5. So I can take that 0.5 and I'm going to sub it into my original equations. We're not going to deal with these equations that we manipulated anymore. We're going to go right back to our originals. So when I go back to an original equation, I'm going to use 5x plus 4y equals negative 28. And I'm going to sub in 0.5 for my y value. So I have 5x plus 4 times 0.5 is equal to negative 28. So 5x plus 2 equals negative 28. I'm going to subtract 2 from both sides. I am then going to need to combine these. So I have 5x is equal to negative 30. And I'm going to divide both sides by 5. So I have x is equal to negative 6. So my solution is x equals negative 6, y equals 0.5. So as a point, it is the point negative 6, comma 0.5. And I can check my solutions to verify they are correct by going 5 times 6, negative 6, sorry, plus 4 times 0.5 equals negative 28. If you type it in your calculator, you should get negative 28 is equal to negative 28. So that one will verify. And the next one will be 3 times negative 6 plus 10 times 0.5 is equal to 13, negative 13, sorry. So I have 18, negative 18 plus 5, so I will get negative 13 is equal to negative 13 when I type this in my calculator. That tells me that my solutions have been verified, and this solution is the solution that I was looking for. And our last question here, once again, does not have anything that is the same about it, so we're going to have to make something the same. In this case, I'm going to deal with my y values instead of the x values. We did x last time, we'll do y this time. And in order to make the y's the same, I'm going to have to multiply this one by 3 and this one by 2. So I'm essentially multiplying the equation by its opposite coefficient. So the coefficient of y over here was 3, so I'm going to multiply this equation by 3. Coefficient of y here was 2, I'm going to multiply by 2 over here. So when I wind up doing that and I multiply all this together and I've got it all multiplied out, I wind up with 9x minus 6y is equal to 33. And I wind up with 14x plus 6y equals negative 102. Now what I can do is I can go through and I can set these up as an add-in or subtracting equation. So I can go 9x minus 6y is equal to 33. And I have 14x plus 6y is equal to negative 102. I'm going to make sure that these line up. When I do this, I need to know if I'm adding or subtracting these equations. In this case, I am going to be adding them because a negative 6 plus 6y is going to give me 0. So we're going to add these equations together. And when I do that, I'm going to get the following. 9x plus 14y is going to give me 23x plus negative 6 plus 6 is 0y. And 33 plus negative 102 is going to give me negative 69. So I have 23x equals negative 69. I'm going to divide both sides by 23. And when I divide both sides by 23, I get x is equal to negative 3. I can then take that negative 3, sub it into one of my original equations. So I'm going to choose to use 3x minus 2y is equal to 11. And I'm going to go 3 times negative 3 minus 2y equals 11, negative 9 minus 2y equals 11. I'm going to add 9 to both sides. And I'm going to get negative 2y is equal to 20. 9y is equal to 20, sorry. Yeah. Divide by negative 2, sorry about that. Divide both sides by negative 2 and I get y is equal to negative 10. So I have a solution of x equals negative 3 and y equals negative 10. So my point is the point negative 3 comma negative 10. And once again, you can verify by checking your solutions. So we're going to sub in, I'm going to have 3 times negative 3 minus 2 times negative 10 equals 11. And I'm going to get, when I type that in my calculator, 11 equals 11. And for the next one, I have 7 times negative 3 plus 3 times negative 10 equals negative 51. So negative 21 plus negative 30 equals negative 51. So negative 51 does indeed equal negative 51. So those solutions verified, they check out, everything is good there. Last one here, I want you to do it on your own. So pause the video, try it on your own, come back, make sure that you got what I got. All right, now that you have gone through and you have figured out what you needed to do, I started by getting rid of my x's, so I multiplied my first equation by 4 to get 12x plus 16y equals 16. Multiplied my second equation by 3 to get 12x minus 72y equals 39. I set them up right here where I was subtracting the two, so 12x plus 16y minus 16 minus, and I put my equation in brackets, 12x minus 72y minus 39, so I got 0x, 88y, and 55. Solve for y, and y was 5 over 8, or 0.625. If you're using the decimal, you have to use all the decimal points given to you, or your answers will not be correct. So remember, if you're taking it using the decimal sign, use all decimal points given to you on your calculator. I then subbed the 0.625 into the equation 3x plus 4y equals 4, solve for x, and got 0.5. When I did my verification or my check, I did get negative, or I got 4 equals 4 and negative 13 equals negative 13. So my solution can be 0.5. comma 0.625, or 1/2, comma 5/8. Whichever way you prefer to write it, I will accept both answers. So these are both correct solutions.